Hi, I am Kamaksha Musunuru. This is one of demonstrations which belongs to a series of presentations on a small web application which I developed recently. I call it as Advanced Data Systems for Business Analytics. This application is going to help a lot for all students, research scholars and faculty members, but for pilot and survey data analysis. In my previous video, I've explained all these three components of business analytics, namely descriptive data analysis, predictive data analysis and exploratory data analysis. In this video I'm going to show you a special menu which I added to predictive data analysis called forecasting. Let me open the datasets. I have one of my datasets. This is just a fictitious and simulated dataset using a couple of functions in LibreOffice Calc. Just don't worry about this. I have three variables in the data for time series analysis. First one is the serial number, second one is the actual data. Maybe you can imagine this as stock market returns or something like that. And there is a special variable which, it's not very much important. I just created to compare. It helps me to compare with X while performing the analysis. And for this analysis it did not have any sense. Now once you upload the data, let me take you to the plots, and there you can choose the variable which is the actual data variable and press the scatter diagram. Now you can see that there is very little speculative trend in the data. The curve is little like convex, and it goes a little goes to the right top corner and from the middle of the graph. So it is clearly visible that it has a little bit of trend in the data. It has a little bit of trend. And now let me go to the forecasting and show you how to choose the variable, and then there are a few methods which you can perform on the data variable. This is the description, which provides very minimal documentation for all these tasks. And now the very first task can be converting the data into the time series data. That is the first step in performing time series analysis using R programming language. Now if you press convert data, your actual data will be converted into, it's not going to do anything. There is no conversion cannot happen into partitions, like the default value for frequency is 1, default value for start is 1. So that I just wanted to keep the data having exact resemblance with the actual data. So it should there are 50 data points in my, and I wanted to keep all 50 data points in the data. If I change frequency into 4, then perhaps things will turn different. Now make stationary is so suppose if I keep convert selected and go bottom and choose TS, then it is possible for me to see the time series conversion in the form of a graph. Here you see the plot is different, right? This is not time series plot, but whereas this is time series plot, we have the plot here, and you can see that from here little speculative trend in the data. Now this is what is called conversion. Now let me show you how to make the data stationary. This is another method. Suppose if you have some trend seasons in your data, it is possible for us to we first need to convert the data into we have to make the data stationary so that we can perform some analysis. For that we have a method called stationary, and here you can see the difference. Now the data is around 0. Instead we don't have that upward trend in the data. And there is another method called decompose, and this method decomposes the actual data into 3 different components, that is seasonal, trend and random. And this method requires an input argument. You can either choose additive or multiplicative. If I choose additive, and we'll be decomposing the data by using the additive modeling or model, where the regression equation, the equation is going to be yt is equal to something s plus t plus r plus e, something like that. If it is multiplicative, then we'll be performing multiplicative model. We'll be using multiplicative model, which means s multiplied t multiplied r multiplied e, something like that. And this is all about decomposition. You have the actual data converted into the quarters. This is actually default value. I supplied 4 quarters. I just wanted to, in my future development I'll be able to give a feature here so that the users can choose the number of this is what is called the frequency. Frequency is equal to 4 is the value for the 4 quarters, and in future developments if users can choose a value for it. This is seasonal component, and this is trend component, and this is random component, and now you can see this is a additive multiplicative model. And now there is a beautiful graph. This graph appears here because I have TS selected. If you choose no plot, your plot disappears. It's better to keep it selected. Now you can see this is a random component of your actual data, time series data, and this is seasonal component, and this is the trend component. You see how beautiful it is. Now this is observed data. This is actual data, trend, seasons. These are 3 different components of the actual data. So by decomposing, what we are trying to do, we are dividing the actual data into 3 different components, namely trend, seasonal, random. Now there is another method called detrend, which means we wanted to get rid of this trend component. So that what happens if we the time series analysis is all about observing, forecasting and predicting trends, seasons, and seasons of the of some particular phenomenon called sales, demand, something like that. So now if we press detrend, the data will get rid of the trend component, and this is how the data, in all plots the data seems to be, but there are little variations. You need to have a very keen eye on the plots to cognize the differences across. Now it is only possible for me to display only 6 first elements of the data set, and because otherwise the entire window will be clogged with a lot of data points. But anyway, here I have only 50 data points, so that's not going to be a big problem. But if you have 100 or 150, the entire window will be filled up with all data. That is why I just and here that information is very clear. Only first 6 records of the for 10, and even for the season. This is deseasonalized. You see there is trend here. Now season disappeared. You go to the trend, there are seasons still, but for the seasons there is upward movement, but those seasons disappeared. Now we can also implement autocorrelation function. So these are the correlation values. You can see some of the values are negative, some of the values are positive. This is a ACF graph, and this ACF, P, ACF are very, very important to decide parameters or input arguments for ARMA, ARIMA, ARCH kind of things, and that is not implemented in this menu. And in my future developments I will be able to provide ARMA, ARIMA, ARCH and all everything. Or if you really have a pressing need, you can write me. My contact details are here, so that I can just change this application which match to your needs, but you need to contact me for that. Now prediction is not implemented right now. This is just again a trend curve, but it just gives the moving averages, because here moving averages, since it is not implemented, it straight away go to the next method, moving averages. And you know what is the moving average? The same frequency one. Moving averages is computed on the converted data, time series, which means on time series data. This is a moving average. By default, the moving average number of data points considered for the average is 1. So these are the moving averages, but the n value for this particular function is 1. And now you can see this is what is the output of the moving average. And there is also a method for the exponential smoothing. By default, this web application uses Holt-Winter method for, and these are the parameters alpha, beta, gamma for the Holt-Winter. This is actually a special case of the exponential smoothing. volt winter. Here you can see the frequency for start value 1 for this implementation, and now these are the coefficients for A, B, S1, S2. You need to read the theory in order to understand, because it is not the idea of this webcast is to provide how to implement the web application, not to explain each and every parameter. And if you really know what is the volt winter function, it is very easy for you to interpret all these values. And now there are a couple of statistics to determine whether the given time series is stochastic or stationary. These are the tests for the stationary data. Augmented decay Fuller test is very important test to perform and decide whether the given time series data is stationary. Now the alternative hypothesis is stationary, which means the null hypothesis by default is stochastic, which is there are random changes in the data. Now if you observe the p-value, it is greater than 0.05. So at 5% significance level, we don't have enough evidence to state that the data is stationary. It is stochastic. And there is also another test, KPSS test. It is also regarded as one of the important tests. You can see the p-value is 0.1, which is greater than 0.05. So again, we failed to reject the null hypothesis. The data has some random changes, so perhaps we can go for the random forest or something like that. There are a few methods missing here, because this itself is very I took a lot of time to provide all these methods through this web application. In future, I may be able to develop some arrange some of the features like ARMA, arch kind of predictive methods, and a couple of few tests like box text, which is very much important for ACF and PSCF. Okay guys, now this is for all about the web application. Now thanks for watching this video, and stay tuned for the new content, and like my video if you really like this, and stay tuned, subscribe to my video channel.